Hello again. We're continuing Module 8 on interval estimation. We've already discussed how to estimate a mean, and now we want to talk about estimating a population proportion. There's many situations in statistics where somebody is interested in the proportion of a population that has some characteristic. I give just a few examples here. What proportion of people will vote for a certain candidate? What proportion of our customers saw our recent advertising campaign? What proportion of sales are coming from our online website, and so forth. So there's many things in both business and economics and society where proportions are of interest. So we want to be able to estimate a population proportion. Our confidence interval or interval estimate for P will actually be quite similar to those that we developed for means. Here's our formula that we're going to use to estimate a population proportion. We're going to take P bar, our sample proportion, plus or minus the correct z-value times the square root of P bar times 1 minus P bar over n. Let's go back for a moment. Let's go back to our original formula for means and just talk about similarities here. Remember our initial formula for means? X bar was our best point estimator of a mean. We have our z-value, which will determine the level of confidence. And we had the standard deviation of our point estimator, sigma x bar. Remember that sigma x bar was equal to sigma over the square root of n, so the formula became as follows. Now our current formula, like I said, is going to be really quite similar. Our best point estimator of a population proportion is going to be P bar, or sample proportion. Now you might remember from Module 7, I believe it was, that the standard error of the sample proportion is equal to the square root of P times 1 minus P over n. You'll notice we've modified that here to be P bar times 1 minus P bar over n. The reason for that is, of course, we're now assuming that we don't know the true value of P. We don't know the population proportion. Therefore, we're going to have to estimate it in this formula with our sample proportion P bar. Fairly similar to when we didn't know the population standard deviation for means, we had to use the sample standard deviation. Now don't forget P bar is the sample proportion. Recall that P bar can be simply calculated as x divided by n. X items that have the characteristic we're interested in out of a sample size of n. If I took a sample of 500 voters and 300 of them favored a particular candidate, then 300 would be x and n would be 500. 300 over 500 would be 0.6 for our value of P bar. As usual, z alpha over 2 is the z-value providing an area of alpha over 2 in the upper tail of the standard normal distribution. And we're going to be going plus or minus that distance, so alpha over 2 will be in both ends of the distribution. Let's do a problem. In a recent survey of 500 voters, 260 of them felt that the economy was the most important issue in an upcoming election. Compute and interpret a 98% confidence interval for the population proportion of voters who feel the economy is the most important issue. Notice we're using a little different level of confidence here than we usually use, so we'll have to get a different z-value than we have normally been using. Our sample size here is 500. We surveyed 500 voters. X is 260. 260 of them felt the economy was the most important issue. So from that we can get P bar. 260 over 500 is 0.52. That's our sample proportion. As I'll show you in a minute on a table or on a graph, the z-value for 98% confidence is about 2.33. It's actually in between 2.32 and 2.33 on your tables, and your calculator would probably give it in between there also. That's all we need to know now to calculate our confidence interval for the proportion. We take our sample proportion, 0.52, plus or minus 2.33, times the square root of 0.52 times 1 minus 0.52 over n of 500. Working it on out, you will get a final confidence interval of 0.4681 to 0.5719. So we are estimating that P, the true population proportion, is somewhere in that interval. So we interpret this by saying with 98% confidence, we estimate the population proportion of voters who feel the economy is the major issue in the election to be between 0.4681 and 0.5719. If you're not sure about the z-value of 2.33, here's how you would find it. Go to your z-table. We want 98% confidence. Remember, that's the area in the middle of the distribution. And that means the other alpha percent is half out here, 1% out here, and 1% down here. So if you work backwards on the z-table, you should be able to find that those z-values are plus or minus 2.33. You could go to your negative z-table to find this one. Simply find a z-value that leaves a cumulative probability below it of 0.01. So you'd look in the table, in the middle of the table for 0.01, look in the row and column, and it should be pretty close to negative 2.33. By symmetry, this will be the opposite, the positive side. Let's do another problem. A retail firm desires an estimate of the proportion of customers who use credit cards when making a purchase. They take a random sample of 400 customer purchases and finds that 280 of them used credit cards. Calculate and interpret the interval estimate of the population proportion of credit purchases. Use a 90% level of confidence. Again, calculate your sample proportion, P bar. X over N, 280 out of 400 used credit cards. That's 70%, or 0.7 in decimals. We've had it before. The z-value for 90% confidence is 1.645. And now we're ready to plug everything into the formula. 0.7 plus or minus 1.645 times the square root of 0.7 times 0.3 over 400. Work it out step by step, and you will get a final estimate of 0.6623 to 0.7377. And we are estimating that the true proportion of credit card users falls in that interval. So with 90% confidence, we estimate the population proportion of customers of this retail firm who use credit cards is between 0.6623 and 0.7377. If you want to do a confidence interval for a proportion on your TI 83 or 84, you will do the following. Once again, press the Stat button, scroll over to Tests, scroll down until you get to one that says 1 proportion Z interval is the abbreviations. On my calculator, that's letter A. It might be different on yours. Hit enter. All you have to do now is enter your X value, enter your N value, enter the level of confidence you want, go down to calculate and hit enter. And you should get the confidence interval that you desire. That's it for part 3. That's all we do with confidence intervals for a proportion. Next, we will take up the question of determining the sample size.